Hello, welcome. In the last few episodes we've been building this. I'll just show you what it does. You can see that we're adding these two numbers and we get an output of the result, and then we add these numbers and we get this result, and it remembers this result. So we now have the beginnings of a computer, but it's more like a calculator right now. And even a calculator is more powerful because all this can do is add two numbers and that's it. So how do we move this a little bit closer to what a computer actually does? Because we do have the beginnings of a program on the left here. And on the right, it remembers the result, but it can't use the result in another computation, whereas even a calculator can do that. So, yeah, I guess we should move towards that. So, one thing that we can do is kind of clean up everything that's happening on the right-hand side here. This structure here, where we've got a D flip-flop and a multiplexer that feeds the result back in when this line is not activated. Otherwise, if this line is activated, it takes an input. This structure right here is what is called a register. And this program does have built-in registers. This becomes the enable line on the register. This line here is the D line. This is the clock line here, and Q is that right there. So let's replace these with these. Okay, let's just verify we haven't broken anything. And we haven't. Oh, but the outputs are now in hex again. Let me fix that. There we go. That's working. So this here is actually called register file, and it's a very common component in a computer. Well, it's not quite done yet though, because we need to be able to read. So let's build that. So in order to read these registers, we need to be able to select one of them as the register to read, and a multiplexer will do that. Okay, so let's get some values in here, and we can select which one we get on the output here. Again, it's in hex. So I've named this RS for register source. So this whole thing is what is known as a register file. We do have the beginnings of a register file here. Let's copy and paste this into there. There we go. So we need some inputs on here. I'm using the clock input because it acts in a special way in the measurement graph, which I can show you in a bit. This portion here is also known as a decoder when you just pass a single 1 bit into it. So let's actually use a decoder. Let's call this RD for register destination. So this would be the register that we're writing to. Okay, so if we open this like that, you can see these bars here. That's because we're using the clock input, and it knows how to deal with the clock, and it tells you what's happening on each of the control signals on each clock pulse. So that's why we would want to use a clock pin in order to get nice pretty graphs. And also the clock pin shows up with this triangle on it, which you'll see in a moment. Okay, so we have our circuit. It appears to work. We can test it out a little bit. Yep, seems to work. I've already set up some of the settings in here. Okay, so we have this, and you can see the clock has the little arrow bracket on it, which is nice. I think we want to rearrange some of the pins though. It'd be nice to have this output on top, and for the inputs it would be nice to have the clock probably on the bottom. Otherwise these are good, I think. So let's replace this part on the right with our new register file. All right, it appears to be working. We have both the register source and the register destination just tied to the program counter for now. We have a B output that's currently showing the output of RS, which is going to be the previous value of whatever's in that register. So if we restart, you can see that B is 0 until we get here, and you can see that now we're picking up the 154. So this is all good, and this is looking a lot simpler. Let's complicate it again. We want to be able to use this B output here as the B input here. There we go. Now what's going to happen? So we only get the A input here the first time through, but now we're going to get 200 here, 400. So it's essentially doubling it each time we iterate through, because it's just adding the number A here to itself. So still not quite useful, but we're getting there. I guess then we need to change our instruction format in order to incorporate this. So let's do that. This is a pretty simple circuit. All we're doing is splitting the instruction into two parts. Let's change the way that we're doing this. Let's instead have two 2-bit values. That'll select the source register and the destination register. That seems pretty flexible. And then we'll have 12 bits that we're not currently using. And in the end, we're going to change this to 16-bit instructions. We just need the room for now. So I'll leave it as 32 bits. So then now this doesn't make sense. Let's call this our S. And then we need an RD. There we go. Yeah, so instead of taking the program in, let's send this in. There we go. Now what's it do? Oh, that's interesting. It's interpreting our B value as the set of registers that we want to change. That's interesting. I wonder. Why don't we change this a little bit? If we change this to a 4-bit number, then we can use a hexadecimal digit to select which registers, the source and the destination register. So let's actually do that. Let's keep the output as 2 bits. Let's just do this. And let's offset this by 2 bits. So then we can use a hex digit to select the source and the destination. Yeah, I'm liking this. Okay. So then we need to switch these to hex. And we need to change our defaults. Okay. So what I've done is I changed this input to be in hexadecimal again. So then the leftmost digit in here should be our source register, and the rightmost digit should be our destination register, numbered the same way that they're numbered here. So that's why I called this SD, being source, destination, source, destination. So this ends up being an 8-bit number that we put into this splitter. In the decoder, what we do is we space these out. So this is a complete 8-bit number right here. Just 4 sets of 2 bits. And we take the first 2 sets as our source, and we take the second as our destination. The first 2 bits of the second set as our destination. So what it's doing is it's taking the source register and putting it in the destination register. Oh, I might have these backwards because it put it in R0. You can see kind of tiny little numbers here. I'm using that to kind of troubleshoot. Okay, so we've got the first instruction. It is the destination register is 0. Okay, yeah, so I do have them backwards. Let's fix that because I feel like source and then destination is a more intuitive way to do that. So we can fix that in our decoder here. Just got to swap these around. Here we go. So the source is going to be register 0 here, and the destination will be register 1. So when I click this, it puts 100 in here because it's taking A and whatever's in B, which was 0, but now it's 100. So what this is going to do is it's going to take 100 and add it to 200. So we should expect the result here to be 300, which it is. And now it's going to take 300 and add it to 99, I believe. We'll get 399 in R3, which we do. And now I switched it to taking the source register R3 and storing it in R0 again. So R0, instead of being 0, will be whatever 399 plus 34 is. 433 apparently. And then now every time we go through here, we get completely different numbers. Because now we're able to specify both source register and destination register in our instructions. So now our instructions are a little bit more powerful thanks to a register file. So I think this is a pretty good place to end it for now. I know this was more of a refactor episode, but yeah, I mean, that if you don't refactor as you go, you end up with a jumbled mess. And now we have the jumbled mess hidden from us in a subcircuit. So all of these crisscrossing wires, we don't have to worry about it. We just have a nice clean box that hides that away from us so that we can concentrate on building a different mess of wires somewhere else. Although, yeah, the idea of using hex digits to select the register kind of keeps this a little bit more clean than I was expecting it to be. But this is good. So please give feedback if there's any boring parts or you feel like my editing made things super confusing because something was lost. Please leave a comment down below. I'm very open to learning how to do this better. So thank you very much for watching. Have a great day.